Hello everyone, and welcome to lesson 1.9, polynomial functions from data. Now, before you watch this lesson, make sure you've already completed the investigation sheet that I handed out in class the other day. You should have finished the finite differences on that page, and if you want to double check your work, make sure you check out the website because I've uploaded a filled out version for you. What you should have gathered from your investigation is that when your first differences are equal, you know you end up with a linear function, a function of degree 1. When your first differences aren't equal, you go ahead and you continue to find your second differences. And when your second differences are all equal, you know you end up with a quadratic, and so on and so forth. So third differences are equal, tells me I have a cubic function. Fourth differences, a quartic, and on and on and on. We will be given a table of values, and we are going to determine the function that gives us those points on that table of values. So first we're going to take a look at our finite differences and determine whether we have a quartic, a cubic, a quadratic, or whatever type of function. So we'll determine that, and then the next thing we're going to determine is our leading coefficient. Now there are a couple of ways to do it, but I find the best, most efficient way is to use this sort of shortcut. So just for now, and I'll explain it how to use it when we get to it. But just for now, know this formula. So our A value, our leading coefficient, is found by calculating the value of the finite differences divided by n factorial. So just for now, let me explain what a factorial is. For example, if I had 5 factorial, all that means is I will start with the number 5, and I'm going to multiply by the number below it, and the number below it, and so on and so forth until I get to 1. So I know that 5 factorial is equal to 120. Again, let's say I had 3 factorial. Well, I start with 3 and multiply by 1 below until I get to 1, so I know 3 factorial is equal to 6. So that's how you work factorials. Okay, so here's the example that we are going to work through. We are given a set of points, and we want to find the polynomial function that these data points represent. And so we're going to come up with the equation for that. So we will put these points into our table of values. So we have 1, 4, 2, 3, 3, 16, 4, 55, 5, 1, 32, and finally 6 and 2, 59. So first things first, we need to determine what kind of function this is. So let's calculate our finite differences. Remember, it's always bottom number take away top number. So we have 3 take away 4, 16 take away 3, 55 take away 16, 132 take away 55, and finally 259 take away 132. Clearly, our first differences are not equal. So I'm going to take that and I'm going to move on and calculate second differences. So again, bottom take away top. 13 take away negative 1. 39 take away 13. 77 take away 39. And 127 take away 77. I know I don't have a quadratic function, so I'm going to move on to third differences and subtract. 26 take away 14, 38 take away 26, and finally 50 take away 38. So I take a look at my third differences and I see I have all 12s, so I must have a cubic function. Now remember that a cubic function in standard form looks like this. Y equals ax cubed plus some coefficient x squared plus some other coefficient x plus our constant d. Now, we have 4 variables, but we can figure out the first variable right away. We can figure out the value of a using the formula on the previous screen. So we want to calculate our a value. Remember, it is the value of the nth finite difference divided by n factorial. Now what n represents is the difference that you had to go to. So because we went to third differences, our n value is 3. So the value of my third difference is 12. And then n, again, represents the difference that we had to go to, so I'm going to divide by 3 factorial. Okay, let's calculate 3 factorial. 3 times 2 times 1. And then do our division, and finally we end up with an a value of positive 2. So I can rewrite the above function as y equals 2x cubed plus bx squared plus cx plus d. Okay, so what we're going to do is we will use this equation, and we're going to create 3 equations so that we can use elimination to solve for b, c, and d. So just go to a clean page so we have a little bit more room. There's our equation again. And we're going to use the points from the table so that we can start creating our equations. So I'll just go back again. The first point we're going to use is 1, 4. Remember that x is 1, y is 4. So we'll sub that in to our equation. So y equals 2x cubed plus bx squared plus cx plus d. And then we'll do a little bit of simplifying. So 4 equals, remember BEDMAS rules, exponents first, 1 cubed times 2 plus 1 squared times b plus c times 1 plus d. And I'm just going to go ahead and move all the constants to the left side. So I'm going to move this 2 over, and we're left with 2 equals b plus c plus d. So I'm just going to kind of square that off and put it in our back pockets, and we'll come back to that in a second. Just label it as equation 1. So we're going to go back and get another point. The next point we need is 2, 3. So we'll do the same thing. Y equals 2x cubed plus bx squared plus cx plus d. And simplify. So 2 cubed is 8 times 2. 2 squared times b. C times 2. And plus d. And again, we'll simplify. So we'll move the 16 over. Gives us negative 13. And this we will call our equation 2. Now, because we have 3 variables, b, c, and d, we need 3 equations. So one more equation. I'll go back and grab one more point. So we'll use the point 316. And same thing. So y equals 2x cubed plus bx plus, bx squared plus cx plus d. And simplify. So 3 cubed is 27 times 2 plus 9b plus 3c and finally d. Now 16 take away 54 gives us negative 38, 9b plus 3c plus d. This is our equation 3. Alright, so what we're going to do now is use some elimination. So let's go back to grade 10. And the first thing we're going to do is subtract equation 2 from equation 1. So I'll set that up. Here's equation 2. And here is equation 1. And the reason I chose equation 2 and equation 1 is because if you take a look at the last term, these have a common coefficient. So remember from grade 10, when they have a common coefficient, you can either add the equations or subtract the equations to eliminate that variable. So that is why I want to subtract, and we are going to eliminate d. So negative 13 take away 2 gives us negative 15. 4 take away 1, 2 take away 1, and then 1d take away 1d, gone, eliminated. So what we've done now is we've created an equation. We've created an equation with two variables. We will call this equation 4. Because what's going to happen is I'm going to do this process one more time so that we can create another equation with two variables, and then that way we can subtract those and eliminate another variable. Okay, so next I'm going to choose to use equation 3, and my personal preference is to go back and always subtract equation 1, and the reason being is because equation 1 is so nice because every variable here has coefficient 1, so it just makes the subtraction that much easier. Okay, so I'll set it up. Negative 38 equals 9b 3c plus d, and then equation 1 b c and d. So when I go ahead and subtract, negative 38 take away 2, 9b take away 1b, 3c take away 1c, and then d take away d is gone. So we're on the right track. We've eliminated d again. We'll call this equation 5. And so now equation 4 and equation 5 have two variables. So I'm sure you can imagine where this is going now. We're going to go ahead and use equation 5 and 4. We will subtract them and eliminate another variable and then solve for the remaining variable. Now before I can go ahead and subtract them, I need common coefficients. So if I decide to do equation 5 take away equation 4, well, 8b take away 3b will leave me with some value of b. 2c take away c will still leave me with some value of c. So I haven't eliminated anything. What I want to do is, if I choose to eliminate c, I would like to multiply equation 4 by 2. Because what will happen then is we'll have 2c from equation 5 and then 2c in equation 4, and then they'll nicely eliminate each other. So let's set that up. Here's equation 5. And then I want you to multiply everything in equation 4 by 2. So this ends up being negative 30. This is 6b, and now 2c. Now as you can see, the c's will eventually subtract and eliminate each other. So we have negative 40 take away negative 30, 8 take away 6, and then 2c take away 2c. So the best part of this is now we are left with one equation with one variable. Very, very easy to solve. Divide both sides by 2. So we are given, or we have found, that b is equal to negative 5. So we are going to take this information and we are going to work backwards now. We are going to take this b equals negative 5 and we are going to sub this into either equation 4 or equation 5. I'm going to choose equation 4. And the reason being is once I've subbed in negative 5 here, c has a coefficient of 1. Makes it just a little bit easier to solve, but it really doesn't matter which equation you sub it into. So I'm going to take this equation here. Okay, so there is equation 4. I now know that b equals negative 5, so negative 15 equals 3b plus c. Well, negative 15 equals negative 15 plus c. And when I solve for c, I move this negative 15 over. C ends up being 0. So we've discovered that a equals 2 much earlier on into this lesson. We've discovered that b equals negative 5 and c equals 0. So I'm going to take all of that information and we're going to sub into one of our first 3 equations, either 1, 2, or 3. And as you probably may have guessed, I'm going to choose to sub it into equation 1. Again, because all of the coefficients are 1, and it just makes life a little bit easier. So I'm going to take equation 1, and work with that. So 2 equals, remember b equals negative 5, c equals 0, and we're just solving for d now. If I bring these values over, so 2 plus 5, I guess plus 0, we figure out that d is equal to 7. So now that we figured out what b, c, and d are, we're going to take all of that information and create a therefore statement saying the equation is y equals 2x cubed plus b. So in this case, I should not write a plus. I should say minus 5x squared plus 0x plus 7. And you don't really need to write the 0x, so that would be our final answer. This is the equation that will give you all of the values in our table of values. So that is it for today's lesson. I will just kind of give you a summary of what each function should look like. Remember that linear functions would look like that. A quadratic. So we'll start off with coefficient x squared, and then some other coefficient with x, and then a constant. And I'm sure now you can kind of see the pattern. So we start with x cubes, then we'll move to x squareds, then x's, and then a constant. For quartics, start with x to the power 4, then x cubed, then an x squared, and this would be very fun to solve. Then an x, and our constant, and so on and so forth. So if you ever needed to create some sort of high degree function, you would know what it would look like in standard form. So that's it for today's lesson. Make sure if you have any questions, you ask me in class. Take care, guys.